Hello students, welcome back to my YouTube channel. In this video, I will be explaining the 12th question of Combined Mathematics Paper 1 Part B. Right. So we have already discussed up to 11th question in the 2019 A-level past paper, and in this video, I will explain the 12th question. Right. So Combined Mathematics 1 Part B. Now we are going to discuss the question number 12. Right. So here we have been given two questions in permutation and combination and in series. Now first we will look at the question that came in permutation and combination. Permutation and combinations. Now, before we read the question, first let me explain some basic concepts regarding this permutation and combination, because these two concepts are very important in mathematics. Now, permutation means this is like arranging objects, right? For example, in a group, we have some elements, right? So we have some elements. Okay, let me take A, B, C, D like that. Okay, so I'm going to take 4 letters from English alphabet: A, B, C, D. Now, from these 4 letters, I'm going to pick 2 letters and I'm going to arrange them, right? So I just pick 2 letters, right? So otherwise, okay, let me take all these 4 letters and I'm going to just take 2 letters, right? 2 letters from these 4 letters, and I have to arrange them. So when I arrange them, order matters here, right? So permutation means arranging objects. So if I consider these letters as object, now I'm going to arrange these objects, right? Objects. Now combination means just combining objects. So when we combine objects, order doesn't matter. Now if I take A and B, now A and B are considered a combination. Whether it is AB or BA, those two combinations are considered, or those two groups are considered as the same. Now here let's say combining object, just merging, combining objects. Now you have to know the differences between permutation and combinations. Now the main difference is the order. Here order matters. Order matters means, for example, if you take A and B, now AB is a permutation and BA is another permutation, right? Permutation means simply arrangement. But here both AB and BA are considered the same, which means AB, only one AB is the combination, whether BA or AB. A and B are together considered as a combination. That is the main difference. Here order doesn't matter. Order doesn't matter. Now, if I take 2 letters from these 4 letters, now I am going to write down the permutations, possible permutations, right? So, let me write down them here. And before that, here we have equations also, right? So, we denote, now let's say we have n objects in a group and we have to select r objects, right? So, here I have taken 4. So, here n, now if you take a group, here we have n elements. Now we have to select r. Now NCR is equal to n factorial over n minus r factorial into r factorial. So this is the equation. And here for permutation from n objects to from n objects we are selecting r. So the permutation will be without this portion, right? N factorial divided by n minus r factorial. So these are the equations. Now let me consider this example. where I have 4 letters. Out of the 4 letters, I have to take 2 letters. I have to pick 2 letters. Now the combinations might be like this, right? So I can take A and B. So AB, then AC, then AD, right? With A, I can take B, C, and D. Here D, right? Yes. Right. Now, then with B, I can take A, BA, BC, BD. But we don't consider BB. So because we cannot, because we have to, for example, if I want to make pair, I cannot pair B with B. So I have to take distinct letters, right? So BA, BC and BD. Now if I take C, CA, CB and CD. Here DA, DB, DC. Now you see replicates are allowed in permutations. Means here you see AB, BA. So means here A and B are together. Here also A and B are together. However, due to the matter of order, we consider this and this as separate permutation. But in combination, here, if it is combination, now AB and BA are a single combination. So in combination, we will write AB only. Now you see CA is here and AC is here. So these two are considered as a single combination, right? So AC. Now here BC and CB, right? So let me take BC. BC and CB are considered the same combination. Again, you see DA and AD, right? DA and AD. Then again BD and DB, BD. Then this CD and DC. So DC or CD, whatever. Now the number of permutation that we can make by picking 2 letters from these 4 letters is, now combination, number of combination is equal to 12. Here number of permutation is equal to, I'm sorry, here permutation, right? Here permutations, number of permutations is equal to 12. 1, 2, 3, 4, 3, 12, and here 2, 3, 6. Now P is equal to 6. Now these are the basic concepts regarding permutation and combination, and we might have studied a lot of theories, and we will look at the first example. I mean the first question that came. I mean the A part. Okay. Okay, let me read the question and try to do that. Here, let P1 and P2 be the two sets given by A, B, C, D, E. Now we have two sets, P1 and P2. We have two sets and the elements are separately given. So here the set P1 consists of letters and numbers A, B, C, D, E, 1, 2, 3, 4, right? And here P2 contains the letters F, G, H, I, J, 5, 6, 7 and 8, right? Okay. Respectively. It is required to form a password consisting of 6 elements taken from P1 union P2. Now we have to generate a password, right? So we have to take, now from these two sets we have to consider a union of P1 and P2, right? Now we have to generate a password consisting of 6 elements. 6 elements, 1, 2, 3, 4, 5, 6, right? We have to generate a password consisting of 6 elements. now the elements taken from P1 union P2. Now we have to select. Now if you take any of the elements from the password, that should belong to P1 or P2, right? Okay. Which are different letters and three okay, P2, which are three different letters and three are different digits. Now here, out of the six elements, now we have three different letters and different now three letters and three digits, and they should be different. Now now here in the password, duplicates cannot exist, right? So if I use A here, then again I cannot use in the same password. That's the meaning of that sentence. Differently, in each of the following cases, find the number of different such password that can be formed. Now the first one is all six elements taken from or chosen only from P1, right? Taken from P1. Now for the second one, now we have to find out the number of different cases, right? So they are asking about combinations, right? They are asking about combination because here order doesn't matter. Now second one, three elements are chosen from P1 and three elements from P2. Three elements from P1 and three elements from P2. Now this is the question, right? So elements mean you have to be very careful. The elements contains letters and digits. An element can be either letter or a digit, right? Now all the six elements taken from all the elements taken from P1. Now here you see, now let's say the first three elements of the password that we are generating is the first three elements may be letters and the rest three elements may be digits. Now you see how many letters do we have in P1, and we have to select all these six elements from P1 only. So now we have to select three letters from the 1, 2, 3, 4, 5 letters. From the 5 letters we have to select three elements in these positions. So for that the combination is 5C3, right, times. Now again in this place we have to select three digits from 1, 2, 3, 4. So 4C3 is the combination of the digits that we can put in these places. Again, okay. Now this is the combination of letters and this is the combination of digits. Now we have to multiply because we have to find out all the different ways or different cases. Again, now we have selected or we have found out the possible number of cases. Now we have six elements. Again, by shuffling these six elements we can make passwords, right? So you know how to form passwords, how to generate passwords. Now 1, 2, 3 A means again A 1, 2, 3. Likewise we can shuffle the elements among themselves. For example, for that, okay, let me take a simple example. A, B, C, right? Now by shuffling these three elements, now let's say this is my password. Now I can make another password by like CAB. Okay. ABC, ACB, right? And BAC, BCA, CAB, CBA. Now, by shuffling these three letters, I can make six more different password. So the number of letters we have is 3. Now 3 factorial is the number of all possible password that I can generate using these 3 letters. So 3 factorial means 3 times 2, which will give you 6. So 1, 2, 3, 4, 5, 6. Likewise, we have 6 elements here. By shuffling these 6 elements, we can make some number of passwords, right? So 6 factorial. Now, if you simplify this, you will get the answer. Now, here combination, right? So we have already studied the equation for combination. NCR is equal to n factorial divided by n minus r factorial into r factorial, right? So here n is equal to 5. So here 5 factorial divided by 5 minus 3, 2 factorial into 3 factorial times again 4 factorial divided by 4 minus 1, 4 minus 3, 1 factorial into 3 factorial times 6 factorial. Now we have to simplify this one. Now you see, now 5 factorial is equal to 5 into 4 into 3 into 2 into 1. Now instead of this I can write 5 into 4 factorial, which means n factorial is equal to n into n minus 1 factorial. So you should know the properties of these factorials, right? Okay, now I can now 5 factorial into 2 factorial into 3 factorial, 4 factorial into 1 factorial into 3 factorial, 6 factorial. Now, okay, right. Now this will go, 4 will remain. 5 factorial, 2 factorial into 3 factorial into 4 factorial, 1 factorial into 3 factorial into 6 factorial. Now 6 factorial can be written as 6 times, 5 times, 4 times, 3 times, 2 times, 1 time. Now I eliminate this with this factorial. Again you see, this is equal to 6, right? Now 5 times, 4 times, 3 times, 2 times, 4 times, 3 times. So instead of this 4 factorial, I am writing 4 times, 3 times, 2 multiplied by 1. I don't need to write. 5 times 4 divided by 2. Now this 2 and this 2 will go. Now let's check if you get 28,800 by multiplying these numbers. Yes, now 10, right? 10, 20, 12, 12, 144, 12 times 12, 144, again 200. Now, what is the answer? 0, 0, 8, 8, 2. So the answer is okay. Now I made a mistake. I couldn't figure out where I made a mistake while I was doing this question. So you have to be very careful. In the examination hall, these things will happen. Now if you couldn't find out where you made mistake, you will write the answer and leave. So for the final answer, you will lose the marks. So it is important that you shouldn't stress yourself during examination, and you have to freely and you have to leisurely do the questions, especially for calculation parts. Okay, now we will go to the second case. Now the second case says, what is this? Now three elements are chosen from P1 and three elements are from P2, right? So here three elements. So the element can be either number or now here we have letters and numbers, right? Numbers and letters. Now we have to select three elements from P1 and three elements from P2. Now we have to make a chart like this, P1 and P2. Now in P1 we have numbers and digits, right? So here we have letters and numbers. How many letters we have in P1? 1, 2, 3, 4, 5. So we have 5 letters and 4 numbers. And in P2, 1, 2, 3, 4, 5 letters and 1, 2, 3, 4 numbers, 4. Right? Now they are telling three elements. Three elements should be selected from P1. So those all three elements can be letters, or two letters and one number, or one letters and two numbers. Likewise, we have to find out the possibilities. Now you see, from P1 we have to select 3, and from P2 we have to select 3. Now all three elements can be letters. So if we select all three letters from P1, now we have to select the rest three elements from P2, right? So here we have given all the chances to the letters. So numbers will not get any chances. Now after we have selected three letters from P1, we cannot give chances to letters in P2 to enter into the password, because the password initially they told that the elements in the password should contain three numbers and three letters. So we have given the chances for letters in the P1. So here the letter in P2 will not get any chances. So we cannot select any letter from P2. But we can select number from here, 3. Right? Now, if we select two letters, we can select one number from P1 here, right? Now, you see, the password should contain three letters. Now we have selected two letters from P1. One letter we need, so we can get one letter from here. And you see, we have selected one number, so we can select two numbers from P2, right? Now, if we select one letter, from P1, now one element, right? So you shouldn't confuse, right? So these are a bit confusing questions. You have to be very careful while doing them. Now, if we select one letter, but we have to select three elements from P1. So we can select two numbers. Now we have selected one letter, so we have to select two more letters. And we have selected two numbers, we can select one number. Now we don't select any letters from P1, so we take 0. But we have to select three elements from P1. So we select three numbers from P1. So here letters we can select 3, and we don't select any letters from here, any numbers from here. Now we have to find out the number of cases for this combination, right? So you have to make a chart like this. Now number of passwords. Number of passwords. Right. Now, this is also very simple. NCR. So, from 5, we have to select 3 letters. So, 5C3 times. We don't get any permutation from numbers. But here, from 4 numbers, we are going to select 3 numbers. Right? Yes. So, 4C3. Now, after selecting all the elements, we can shuffle them. So we have 6 elements. Again, we have to multiply this also by 6 factorial. Sometimes if you forget this 6 factorial in the examination, you will lose the marks because we have to find out all the number of passwords. By shuffling them also, we can generate new passwords. Now, here 5C2 times, here from 4 numbers we select 1, 4C1 times, here from 5C1 times, then 4, from 4 to 4C2 times 6 factorial, don't forget, right? Then again here 5C1 times 4C2 times 5C2 times 4C1 times 6 factorial, because we have to shuffle the elements also. Now here we don't get any, we don't pick any letters from P1, so we don't need to find out the combination for that. Now 4C3 times 5C3 times, here no need, then 6 factorial. Now if you simplify these expressions, you get the answer as 28,000. Here 28,000, because already we have calculated this, right? So 28,800, because they will not work, they will not make you a lot for a 75 marks question, right? So this is okay. This is also the same, 28,800, right? Because we have already found out the value for this combination in the A part. Now for this, if you simplify, you get 864. Now you see this and this are also same, because you see 6 factorial 6 factorial, 5C1 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 5C1, 4C2 4C2 5C2 5C2, 4C1 4C1. So this and this are same, this and this are same. Now you have to just find out this value, and again you don't need to find out this value, because you have to check whether there is any relationship, because we have to reduce the working, because the examination is time oriented. Now you see, if you just simplify this, you get the answer as 86430. 86430. 86430. Now we have this number of password, this number of password, this number of password, this number of password for these different cases. So what we have to do, we have to add this and this and this. So final answer would be, hence the number of different passwords that can be formed by choosing 3 elements. Now the total number of passwords that can be generated by choosing 3 elements from P1 and 3 elements from P2 will be equal to 28,800 plus 864,000 plus this 864,000 plus 28,800. Now the final answer would be 1785 600. Right? So you know how to add these values. The only thing is, you shouldn't make any careless mistakes. Right. Now we have discussed the A part, for which we will obtain 75 marks. Right? Yeah. And we will discuss the second part now in series.